Good morning, everyone. Happy Halloween. Today we're going to be talking about factoring, and probably this video is going to end up in two parts as well, just because there's several different factoring methods that I want to go through, and this will just kind of break it up nicely for you, okay? So we're going to start on page 108, so if you want to open your course pack to page 108, we can get started, okay? Okay. So, section 5.3, factoring. Yesterday we worked on multiplication of different polynomials. And when we had, for instance, these two binomials, we multiplied them using FOIL or using the box method, and we ended up with a quadratic equation. Now, factoring is the inverse or the reverse process of multiplication, okay? When we're factoring, what we're doing is we're using patterns that we know to be true of a quadratic equation in order to determine what its parts are, okay? So we're using the patterns of what we know in order to determine the parts, okay? So to get you thinking a little bit here, we have an exploration task. If you have a math friend with you, then you can go ahead and do this with a math friend. But what I want you to do is, for the first item, I want you to write a quadratic polynomial that has one factor that is x minus 4. Okay, so if I'm thinking about what this means, I just told you that these two parts, when we're multiplying, give us this product. So if these two parts multiplied together give us this product, that means that both of these two binomials are both factors of this quadratic equation, okay? So if I know that one factor needs to be x minus 4, if this is one factor, I'm not telling you what the other factor has to be. I'm just saying that one of the factors has to be x minus 4. Okay? So when you create your polynomial, we want to take another factor and multiply it along with this factor. So really, you could pick anything. Let's say I pick x plus 2. Okay? Now I'm going to multiply this out. You have x squared plus 2x minus 4x minus 8. And so my quadratic polynomial will be x squared minus 2x minus 8. Okay? This is my quadratic polynomial that has one factor of x minus 4. Okay? Now go ahead and try the next one. Okay, I'll give you a second. You can pause the video and write a quadratic polynomial that has one factor that is x plus 3. Now you will have done this the same way. You started off with x plus 3 as one of your factors. You selected another factor and then multiplied it to get your quadratic polynomial there. Okay? Now for the last part here, we want a quadratic polynomial that has one factor of x plus 5, and when you multiply it, so we have one factor of x plus 5, you have another factor here, and when we multiply this together, we want a polynomial that says x squared plus 3x minus 10. Okay? So I'm going to give you a few minutes to give that a try. Actually, I'm not going to give you a few minutes. I'm just going to ask you to pause the video and go ahead and give this a try. What's another factor that goes along with x plus 5 in order to give us a quadratic polynomial of x squared plus 3x minus 10? Okay. You should have gotten the factor x minus 2. So when we have x plus 5, x minus 2, when we multiply these together, they give us a quadratic polynomial of x squared plus 3x minus 10. Okay? All right, so methods for factoring. Today we're going to talk about these 5 methods for factoring. Okay, we're going to talk about factoring the easy way. This is with polynomials that have a leading coefficient of 1. We're going to factor using greatest common factor. We're going to factor using difference of squares. We're going to factor with grouping, and we're going to factor polynomials with a leading coefficient greater than 1. Okay? So, factoring the easy way. If we start off by considering what we know about how we find a product, let's look right down here. When we have two polynomials that give us two polynomials here, that give us a quadratic polynomial as a product with a leading coefficient of 1, we can consider the same things, okay? When we multiply first, my first two terms in each of these binomials, we get an x squared, okay? So if we have a leading coefficient here of 1, we know that our first terms in both of these binomials is x, or whatever variable we're working with, okay? When we multiply the outside, let me look at the outside here, x times q is right here, okay? Then we look at the inside, px is there, and then we look at the last, pq, which is here, okay? So, looking at these two binomials and how they play out here, what we see is that this first term here comes from multiplying these two, which is x times x, which gave us x squared. This last term here is the last part times the last part. The last term times the last term of each binomial. That's this, okay? This piece that we have in the middle here, the outside times the inside, we see that they have a common factor of x. So when we're looking at how this factors out, this piece right here is the sum of my outside and my inside, okay? So let's take a look at what this looks like in application. Okay, here we have the quadratic equation x squared plus 6x plus 8, okay? Now, we have a leading coefficient here of 1, which means that we know that we're going to be multiplying two binomials, each of them that has an x, okay? We also know this 8 right here, this positive 8, tells us that we want a product of 8, so whatever ends up in this position, we need to have a product of 8, it says right here, and we need a sum of 6, okay? Because remember, this middle term is the sum of the outside and the inside, right? Okay, so once we know that we need a product of 8 and a sum of 6, we're going to consider all of the factor pairs of 8. Okay, if we want a product of 8, we know that we can have the factors 1 and 8, or we can have the factors 2 and 4. Okay, now the other part of this was that in addition to a product of 8, we need to have a sum of 6. So if I look at my two factor pairs here, 1 and 8, that gives me a sum of 9. Here, 2 and 4, this gives me a sum of 6. So I know then that 2 and 4 are the factors that I'm looking for, okay? Because 4 plus 2 is 6, okay? Now, since 4 and 2 fit both of these parameters, that being product of 8, sum of 6, we know that 4 and 2 are the two terms that fit into these binomials, okay? We can check this by multiplying. We multiply together our first, x times x, which gives us x squared. Outside, x times 2 plus 2x. Inside, 4 times x plus 4x. And the last, 4 times 2 is plus 8. Okay? These are like terms, So we can combine those, x squared plus 6x plus 8. Okay, and that is the same as what we had here. Okay, so when we're looking at these, right now we have one quadratic polynomial that says x squared plus 8x plus 12. This tells us what our product is. So we want a product of 12 and a sum of 8. Okay, so now we need to consider if we want a product of 12 and a sum of 8, we need to first look at the factor pairs for 12, which 1 and 12, 2 and 6, 3 and 4. These are my factor pairs. Which of these factor pairs gives us a sum of 8? Okay, you're right, it's 2 and 6. So we have x plus 2, x plus 6. Okay. Okay, now let's look at the next one. Now if you notice, this one's a little bit different. Here we have x squared. Our b value though is a negative 12, but our c value is a positive 36. Okay, so we still want to have a product of 36, but our sum here is a negative 12. Okay, so you notice that we have that written right here. We want a product of positive 36 and a sum of negative 12. Okay, so if we consider this, if our product is positive and our sum is negative, then what we know about these two binomials is that they both will be negative. Okay, because if we multiply negative times a negative, that gives us a positive. And if we add a negative and a negative, that gives us a negative. Okay, so now let's consider our factor pairs of 36. We have 1 and 36. We have 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so looking at these, which of these pairs gives us a sum of negative 12? We want to remember that in this case, we know that both of these are negative because multiply them together, two negatives, it'll give us that positive 36. So now we're looking for a sum of negative 12, which we can see is this right here. So my binomials, x minus 6, x minus 6. Okay. All right. Just look over. Okay. All right. So if we're factoring ax squared, so this is our a, plus bx plus c, and our c value here is positive. Anytime that our c value is positive and our b value is positive, we know that what we have here are two binomials that are going to be positive. Okay, so now we want to find something that has a factor of 21 and a sum of 10. So factors of 21 are 1 and 21, 3 and 7. Okay, looking for a sum of 10, I can see that 3 and 7 give me a sum of 10. Okay. All right, let's do one more together. Here we have my C, which is positive 28. So we want a product of positive 28. And we want a sum of negative 11. Now, if we have a positive C and a negative B, that tells us that we're going to have x minus something and x minus something. Okay? Now we want to find the factors of 28. So, factors of 28. We have 1 and 28, 2 and 14, not 3, 4 and 7. Okay? Now, of these three pairs, which ones are going to give us a sum of 11? It's these two right here. So x minus 7, x minus 4. And those are our two factors. Okay, go ahead and pause the video. Take a minute to solve these three right here, and then we're going to talk about them. Okay, hold on just a second. Okay, so this is what you should have gotten here and here. Now, you probably got to this one and you thought, okay, I need a product of 77 and a sum of negative 19. Now, looking at my factors for 77, I know that I have 1 and 77 and 7 times 11. No matter how I spin this, I'm not going to get a sum of negative 19. If we get to a point where you cannot find something that has a product of this and a sum of this, for now, we are going to call that prime. Okay? So, if you have a polynomial that we cannot factor, we're going to call it prime. Okay? All right. Let's look at the next part here. Here we're going to be factoring this quadratic where our c value is going to be negative. Okay? Now, c is the product. So if I know that my product is negative, then I have to consider, how do I get a negative product? Okay? Now what I know is that I get a negative product by multiplying a positive and a negative. Okay? So if I know that I multiply a positive and a negative to get a negative product, now I have to consider my sum. Okay, my sum is a positive 2. All right, so let's take a look at the factors of 24. I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, now I know that one of these is going to be positive and one of them is going to be negative, but I'm not quite sure which one. Okay, so what I need to think about is I need a sum of positive 2. Which means I need to look at these factor pairs and determine which of these factor pairs is going to have a difference of 2. And I want that difference to be positive. Okay, so looking through at these, I see that this pair right here has a difference of 2. I want my sum to be a positive 2. So that means that my 6 is going to be positive and my 4 will be negative. Because if we have minus 4 plus 6, that leaves me with a positive 2. So I have a positive 6 here and a negative 4. Okay? Does that make sense? Okay, let's look at the next one. Now here we have a negative c. So our product is negative 20. And our sum is actually a negative 1. Okay, so again, we know that if c is negative, we know that we have a positive and a negative factor. Okay, so if I have a positive and a negative factor, now I have to consider which one is positive and which one's negative. Okay, let's look at the factor pairs of 20. Factor pairs of 20. I have 1 and 20, 2 and 10, 4 and 5. Okay, I want a sum of negative 1, so I'm looking for which pair has a difference of negative 1, and that is this pair right here. Now, since I want my sum to be a negative 1, my 4 must be positive and my 5 must be negative. Okay, so I have a positive 4 and a negative 5. Okay, all right, go ahead and try these last three here. I'm going to write the solutions down really quickly. So pause the video and I'll write these solutions down. Okay. Okay. So here's what we should have gotten. This one, and this one. Okay. All right. So if we turn over to the next page here, we have a chart that we're going to fill out. And we're going to say if we have a positive C, positive B, positive C. Okay, so if we have a positive B and a positive C, we know that the factors are both going to be positive. If we have a negative B and a positive C, we know that both of the factors are going to be negative. Okay? If we have a positive B and a negative C, one factor will be positive, one will be negative. If we have a negative B and a negative C, again, one factor will be positive and one factor will be negative. In these last two cases where C is negative, the sign of B is determined by the factors. If the larger factor is positive, then you're going to have a positive B value. If the larger factor is negative, you're going to have a negative B value. Okay? All right, we're going to go ahead and skip this part for now. Okay? Okay, so let's look at factoring the difference of two squares. Now, if we're looking at factoring difference of squares, this is really important because you're going to be looking at difference of squares all through this quarter, through pre-calculus, and on. This will be, difference of squares will be applied later on to trig functions too. So you have to be able to recognize the difference of squares. When we're looking at factoring a difference of squares, you'll recognize that you have an a squared and a b squared. Okay? This is what you'll be factoring. Okay? It says a difference of squares, which means that our sign is going to be negative, and then whatever we have here will be squared, and whatever we have here will be squared. Okay? So anytime that we factor a difference of squares, you'll have factors of a plus b, a minus b. Okay? Now, looking at how this works out, if we're to multiply these together, we have a times a, which gives us a squared. That's our first. Outside is a times negative b, so we have negative ab. Inside is positive b times positive a, so we have plus ab. And then positive b times negative b is negative b squared. Okay? If we look here, we can combine these middle terms. Negative ab plus positive ab, those cancel out. And what we have left is a squared minus b squared. Okay? So this will work every single time. What we have to look for is a squared value here minus a squared value here. Okay? So let's look here. So if we think about this x squared is x times x. 16 is 4 times 4. Okay? So since I notice this is squared and this is squared, and that's a subtraction sign, I have a difference of squares. So then I know when I factor it, it's going to be x plus 4, x minus 4. Just like that. Okay? Now the next one's a little bit different because we have, I can see right away, this is 2 times 2. I can see that this is m times m. There's also a 9 here, but I know that 9 is 3 times 3. Okay, so if I'm thinking difference of squares, then this, if I took the square root of it, I have 3m plus 2, which is this, and then I have 3m minus 2, like that. Thank you. Okay, and that's my solution. 3m plus 2, 3m minus 2. Okay, let's look at this one. Now, similar to the one that we just did, 25 I know is the same as 5 times 5. P squared is the same as P times P. 49 is 7 times 7. And Q squared is Q times Q. Okay, so if I have two things that are squared here, and I have two things that are squared here. Let me show you something up here. A squared b squared minus c squared d squared. We still have something squared here. We still have something squared here, right? You think about if you broke that apart, it could be ab squared, right? And then this distributes to both parts, okay? So if I know that this is the same, what I have is ab plus cd, ab minus cd. Okay, so as long as everything here is squared and everything here is squared, and we have a subtraction sign here for a difference, then we know what we're going to have here is this AB plus CD, AB minus CD. Okay, so same thing down here. We have 5P plus 7Q and 5P minus 7Q, just like that. And that's my solution. Okay. All right. Go ahead and take a minute to finish these other 5 problems. I'm going to move the phone over a little bit and write down the solutions. So hold on. Pause the video and finish those 5. Okay, so here they are. It's that one. And this one here. Now the next one's a little bit tricky because if you look here, we have b squared and 25, but in the middle here, we don't have a subtraction sign, we have an addition sign. So this one actually ends up being prime, okay? Now you might have done b plus 5, b plus 5. If you did this, then and you checked it with multiplication, you would see b times b is b squared. B times 5 is positive 5b. B times 5, positive 5b. That's plus 10b, and then plus 25. Okay, that's not the same thing. All right. And if you switch the signs to b minus 5, b minus 5, multiply it out.